So our first example wants us to create a crazy little game, and there are a lot of rules to go through and I don't want to explain anything, so if you want to know how the actual game works, I urge you to watch the first part of the solution, which will just show you the gameplay and how the game works, and maybe if you want to recreate that, you can try to do that, but otherwise this is more meant as a showing lesson so you can see and then maybe download the code and play with it. But yeah, the main principle is that we'll be actually creating a little game which we move around, we place bombs down, destroy walls and try to get to the exit. Okay, so this is our first and only example, and because I expect this to be our last official video, so to say, before actual Isaac or modding comes out, if of course there are no more further questions or inquiries, maybe someone wants to learn more, what we're gonna be focusing on are just combining all of the things we've learned from the previous videos and using it in this one ultimate big video. And before I go to explain, I think the best explanation to do it is just to run the program and just maybe lead you through it. So what we created is a little game, and this game is basically a maze that we have to go through, similar to Isaac. We can place bombs to destroy walls and enemies, we pick up bombs whenever we walk onto them, and the main thing or the main result we want to do is get to the exit, which is located in the top bottom corner. And of course the player is located in the top left corner, the X's indicate an empty path, the B indicate the bomb pickups, the H's indicate hard pickups, and the W's indicate walls, and of course the O's are enemies. So what we can do, maybe this is a bit confusing at the start, but there are a few commands that we can do to actually walk around. So we just write right, we can see that our player has moved from the first position to the right position. What we can do then is maybe try to write down, and you can see that we cannot move into a wall because obviously you can't go through walls, and you can't go up because we would go out of bounds. So we are constrained to move in this virtual area of the maze we've created. So if we just write, maybe just we just want to pick up a bomb first so we can then place it down and blow things up. So in this situation we got one bomb, we have 10 HP, and we are in this position in this point. Of course if we go back now we can see that the bomb is gone, and what we can do is place it down. So maybe we just want to look where we want to place this bomb down. So if you place it right here where we are now, we can see that we'll have an access to a few hearts and yet another bomb, and then we can blow yet another wall up to get to the exit. Or what we can do is go back to this enemy here, blow him up and get access to yet another bomb, and maybe let's do that just for whatever reason. Let's go back to the other enemy, let's place the bomb down with the command place, and you can see that he exploded, and what happened is that there's an empty space there. Okay, so let's just go down, let's go pick up yet another bomb, and we can see what we can do with that. Okay, before you saw me explode the enemy up, but you might be wondering, okay, we saw that you can't walk into a wall because it blocks you, but what happens if you walk into an enemy? Well, you can see that the spooky monster attacks us and our HP drops by 2, and maybe we don't want to do that again, maybe we don't want to write into the enemy again, so let's just place yet another bomb to kill him. Okay, thankfully now we're in this big chamber which has a lot of enemies, some walls, and things are getting quite uncomfortable, but thankfully we did find a hard pickup, so we're just gonna pick that up, and you can see that our HP actually goes up to 10. Okay, so now we can see that to get to the exit we have to go back to where we were because there's no other way to actually progress here. So what you could do here maybe is even give a local vision of the map, so not show the whole map, but just give the player a vision of where he currently is located, maybe just a few squares around him. But in this situation just wanted to show you the whole map just to maybe showcase it a little bit better. Okay, so let's place the bomb next to the wall so we can get access to yet another bomb. And you can see what happened is when we place the bomb is that the walls adjacent to him have exploded. So now that a lot more paths are open to us. Let's just enter into this cavern to pick up a few hearts and maybe just yet another bomb. And you can see that we are quite healthy at this point, and the last obstacle between us and the exit is this entrance right here. We'll place the bomb right here, you can see that the walls are exploded, and then we can just walk into the exit. And thankfully what happens is the game has finished, we made it out, and that's game over. And maybe I just want to show you what happens if you die, and then we're gonna go into the code and just see how things work. Of course the only way to die is to just run into the enemy multiple times over and over again, 6, 4, 2, and you can see that when we die, we say you died, and that's game over. So that's the game is over at that point, and we have to restart. Okay, so let's get into the code. Okay, so now that we saw how the game works, I just want to go through the code and explain what it does in order to make it work. So the main part of it is the function called printMaze, and what it does, it just goes through this to the array, which is simply just an array that has all the numbers in it, all the letters, and you can see it has the object player in it, has the object enemy 1, enemy 2, enemy 3, enemy 4, and enemy 5, and the rest is basically hard-coded in there as X's, W's, B's, which indicate our walls and bombs and pads, etc. So what this function printMaze does is simply goes through this 2D array and just prints out everything out. So we can see it whenever we are actually playing the game. So we can see our current location, location of enemies, location of bombs, etc. Okay, so that's useful. The next two main classes or objects are the player class and the enemy class, and they have a lot of useful functions. So if you remember how to create a class in the previous one, first of all, we just said attributes. The important attributes here are our HP, the damage we deal to enemies whenever we strike them, and in this case there is no damage. At first glance I did want to implement damage, but there is no damage in this situation. I just left it in, maybe just to show you how you would do it if you were maybe developing a mod for Isaac. The next parameter is bombs, or how many bombs we have, so this means how many bombs we're holding. We start the game with 0, and the first is our location, and you can see that our location, default location is 0, 0. So what happens is when we create a new function, so we create a new object, a new player object, we send in 4 parameters which indicate how much HP damage we have and the position in our map. And the position that we create our character in, we can see this function being called right here. So you can see that we create a player with 10 HP, 3 damage, and the position of our character is 1, 1, which is obviously the thing that we have it set as here, because the arrays in Lua start with the index 1, and the index of 1, 1 can be interpreted as first row, first column. So that means that this is our starting position. Okay, so now that we created our player, we can go see what happens. Okay, so first of all, we create a new key value pair. We just set it into this object. We set the object's HP, damage, and X and Y based on the parameters we set in. So HP of object, the one we created, is the same as HP that we sent into the function new. And this is the same for every other argument. Okay. The next thing that we have, our helper function, is called the move position function, or a move pos for short. So what it does, it takes it's a self object, so that means that whenever we use it, we are referencing ourselves, the X and Y to where we are moving, and the maze in which we are moving in. So maybe if we had multiple mazes, this could be useful, but in this scenario, what we have to do is, first of all, we amend our position. We set our current position to an empty space because when we move to a new position, our current position becomes empty. Of course, that is indicated with an X. We correct our X and Y position to this new position, and we have to set our position in the maze to ourself, which means that we have to move this player character, this player object. Let's say that we move one space to the right, it has to be located in this spot here, and that is exactly what this last piece of code does. It just sets the coordinates of the maze function or of the maze player object. It sets it to whatever its values are in the maze. Okay, so the next one is called move, which means that we have 4 possible movements: up, down, left, and right. And we kind of have to deal with how these things work. So the actual logic for moving is located right here in this main repeat until function, and this is actually the main loop of the game. So what happens in this main loop of the game after we've created the player object, after we created the enemies object, and after we actually created the maze out of them, we set our exit, so where it's located in this scenario, it's located right here. On the X is 7 and Y is 8, and then we repeat the main game loop, so to say. We repeat it until the player gets to the exit, and that's it. So when we get to the exit, we stop the game prematurely. I mean, that's when the game stops. We don't stop it prematurely until we die. Okay, so the first thing we do is print our maze, so we can give the player feedback on where they are located. We ask the user to enter their command. We read the command from the input line, and then we just transform it to the lower string, because when we transfer it to the lower string, then we just have to compare it to the lower string up. So let's just say that we didn't do this. let's just say that this was commented, if the user then entered up, this wouldn't work because the lowercase up is not the same as the uppercase up, which means we would have to write more statements in, or logical expressions, to actually just check all these possible combinations. But a more elegant way to do is just to transform the string of the user or the command to the lowercase and just compare it to the lowercase in our logical expression. Okay? So we can see that there are a few if commands here. Basically what we do is check which command the user has entered: up, down, left, right, or place. Okay, let's just say that he has entered any of the direction commands, so these are the first 4 commands. What we do is check which one it is, and then we amend the player position based on the command. So if the player has moved up, it means that its x value, which is its horizontal value, has reduced by 1. If it has moved down, his x value has increased by 1, which means he's moved down. Or if he's moved left or right, his horizontal or his y value has increased by 1 or decreased by 1 based on which direction he's moved in. So what we do here is basically just add or subtract 1 from each one of the coordinates based on how we've imagined it to happen in our maze. So let's just focus on this one. Okay, so let's say that the position of our player is 1, 1, and you can see that this is the position 1, 2. So let's say that we are in this position and we say move right. You can see just from the fact that this is 1, 1 and this is 1, 2, that a movement to the right increases the second parameter or the second coordinate, which is the y coordinate, by 1. So the right is increased by 1, and of course going left is just the opposite of that, which is decreased by 1. And you can see that all of these commands actually call the same move function, and what the move function does is it exists inside the player object. It checks if the player has moved out of bounds, or maybe if he has moved into a wall. So in this case, the first thing we do is check if the movement that we've tried to make is beyond the borders of our map. So you can see that the first thing we check if the x is smaller than 1 or y is smaller than 1, which means that we're trying to move off the grid, and because there are no indices in our maze that start with 0, we just say you cannot move out of bounds. And the thing we have to check also is the other side, so we don't move over our maze. So that means that we cannot have an indice that's bigger than the length of our maze horizontally, or the same thing but vertically. And if that happens, if those numbers are bigger, so let's say that we are here and we try to move up, the x value is going to be 0, and we're just gonna say, okay, sorry mate, you can't do that because 0 is not a part of the maze, so you cannot move out of bounds. Of course, if none of those is true, which means that we are still inside the maze, we have to check a bunch of other things, and that's why this else if is here for. First of all, the thing we have to check for is if the type we are moving to is a string. Because there are enemies inside, enemies are not always strings, the first thing we have to check, are we moving into a string? And if it's a string, it can be either a wall, a W, an X, an empty space, a B, which is a bomb, an H, which is health, or it can be an E, which is an exit, okay? And then we have to consider all of these things separately. If the maze of the direction we've moved in is W, that means that we just print out you cannot move into a wall, because it's impossible to move into a wall. You can't do that. If you moved into a B, what you do is increase your bump counter by 1, and then you move to that position. So the first thing we do is increase that counter, and then we use the function move position that I explained before to move into that position. If it's a heart, we do the same thing. We increase our health by 2, and then move into the position that we've tried moving in. Or if the answer is E, what we do is we just print out you made it out of the maze, and then we move ourselves to that E position. Or if none of that is true, there's only one option left, that this number or this value is X, we just move to that one and just don't do anything. And if this is not a string, which means that the only other possibility is that we have encountered an O, which is an object, which stands for monster, which means that the value or the type of the monster is not a string. We just say, okay, you walked into a spooky monster, and we just set our HP by so we subtract our HP by 2, and we cannot, and you can see that the move pause does not happen here, which means that we do not move in that position because the monster is blocking us from actually moving there. Okay, so this is actually holds true for all the movement positions. So we just send in the new coordinates to where we want to move, and then we actually consider the options of where we are moving in our move function that exists inside of our object. The last one is the place command, which is we just place the bomb down. And of course, this is yet another function in the player objects, and we just send in the maze where we are placing the bomb on. So we just go in the player, the place bomb function. Let's just see how that works. First of all, we check if we have less or equal to 0 bombs, and if that is true, which means that we have no bombs to place, and we just print this out, and we just return from the function because there is nothing for us to do here. Or if we do have enough bombs, so that means we have 1 or more bombs, we subtract our bombs by 1, because remember we just used 1. We increase our horizontal position by 1, because, or not horizontal position, we just set, we are now checking if the adjacent squares do what they contain. So if they contain a wall or maybe an enemy, we have to blow them up, or if they don't contain anything or are out of bounds, we must not check them. And the first thing we check is the space right above us, and we just use this by creating sort of a helper function x and y here, I mean 2 variables, and then just check that with if the bomb blast is contained within the maze, which means that it is bigger than 1 and y is bigger than 1 and it is smaller than our maze length, then we check if the type of the maze is a string, and if it is a string, and then we check if the type is a wall, and then we change it to x, which is basically saying we just blew the wall up. And if it's not a string, which is the only other possibility that it's a monster, we check if that object is the type of O, which is the monster type, and we set its HP to 0, and then on that position we set the X parameter. There are more elegant ways to do this. This is maybe just one way of doing it. It's not the best way. It would be much better to have this contained as a function, but I really think that this is one of the more complex things that we've done here, because what you have to do is, remember, you cannot just check the upper bound, because what can happen is if this x plus 1 is, or maybe x minus 1 is out of bounds of your array, this is gonna return you an error. So it's very important that you check the indices first to see if they're actually contained within the maze before you actually start checking if the thing you're blowing up is a wall. So that means that if there is a wall above us, we're gonna blow it up and set an X to it, or if there's a monster above us, we're gonna blow it up, set its HP to 0, and set that position to X, which means that there are no more enemies there. And then the same process repeats 4 more times. Like I said, this would be much better if, again, we use the same principle, the same function like we used here, because it's much more self-contained, but maybe I just left it out for people to have a better appreciation, or maybe just have a better understanding of how it works. So in this scenario, what happens, we do the same exact thing. The only thing that changes is that now we're checking the space below us, then we check the space right to us, and then we check the space left to us, and the same exact thing goes right in every single if statement. And remember, if usually you have a block of code that repeats multiple times, it's usually much better to write a loop for it, or maybe even better to just write a few functions for it, which will take care of all that for you, and you don't have to recopy paste all of the code. But what happens, like I said, essentially is exactly the same. We just set our x and y values to whichever space we're looking at. In this scenario, we're looking at a space right below us. If that is a wall, we blow it up or set it to X, which means that it's an empty space now. Or if the block below us is a monster of the type O, which is one of the types of the monster that can exist, we set its HP to 0, and then we set that particular space to an X. And we just do the same thing for the y plus 1, which is the right side of us, and y minus 1, which is the side of the left of us. Okay, so up until this point, this is the main gameplay loop. Basically what we do is check which command the player has entered, we execute that command via the functions we have in our player object, we print out the stats of the player, where they're located, how many bombs they have, and how much HP they have, and then we check if the player's HP is 0 or below 0, and then we just print you died, because that means that the game is over, and then we just break the gameplay loop and we just say game over and the end. Or what we do is we just repeat this until we get to the exit, which is indicated in the exit object here, which indicates where the exit is. And if that is meant to be true, that means that the game is also over, but what we also print out is that we have reached the exit via this prompt here. You made it out. And that is actually all the code that is required for this to work. And there are a lot of things here, I know, and maybe this explanation wasn't the best, but this example is more meant for you maybe to download, play around with, see what it does, maybe play around with it, try to fix it, change a few variables, change a few values, maybe create your own maze, because technically this should work with any maze. I even created sort of a way to have dynamic mazes. It doesn't work the best, but if someone wants it, I can also upload that code. It's just a few functions that try to create a maze that is not necessarily solvable, but it just creates a few random empty spots, some bombs, enemies, caverns, you know, tries to make a dynamic map, basically, something like something like you would have in Isaac, but maybe just a bit more random. So yeah, with that said, that is it for this example, and this is the only example. Like I said, excuse me if this did go by a bit fast, if I didn't explain something well. Please ask questions if you have them, please play with this program if you want to learn more. I think there's a lot of things to be taken here, especially with the object classes. We basically incorporate everything that we've learned up until this point to really create this one ultimate project, game, program, however you want to call it, and I think it turned out pretty well, pretty fun to actually play around with. Thank you for following this example. Again, I will say that all of this is in the description. If you want to download it and play with it, you don't have to retype the code or anything ridiculous like that, so you can just go there and download it and then play with the code in your Lua editor. With that said, thank you guys for watching. This is to be expected the last of the Lua tutorials, at least of the basic ones. When Isaac modding actually comes out, I'll make a few videos on that and show you how you can actually create mods and not just write code. But of course, if you have any questions about today's topic or about any of the previous topics, please, I urge you to ask them. If the question is big enough or if I see that a lot of people didn't understand it, what I'll try to do is create a new separate video which will be explaining just that particular thing. And hopefully that will be enough for us to learn together more about this crazy Lua language. If you have any more questions, please ask them in the comments. Don't be afraid to ask them, because if you're asking them, there's a good chance that someone else is having the same question and you're actually helping more than just yourself. So of course, if you want to know something, or just maybe want to know how to use a function, or maybe something was unclear in the video, or maybe I didn't explain it well, please tell me. I will try to amend that mistake, maybe explain it personally, or maybe, like I said, make another video. Thank you guys for watching, and I hope to see you next time.